The second group of protists, protist pathogens, is a little bit shorter. It is the amoeba ones. And these are both famous. I mean, they're all famous, but these are famous. And they move by pseudopods, so they stretch a bit of their body out, and grab the world, and then pull the rest of their body towards it. And it's weird. Okay, so one of the most severe diseases we will look at in this course is the Meningoencephalitis caused by Naegleria fowleri. This is the one that can grow in warm water, basically thermophilic, like mildly thermophilic temperatures. So in a warm lake, this will grow in the water, and if someone goes swimming and get water in their nose, it can penetrate the olfactory mucosa and travel the olfactory nerve to the brain and proliferate there. And in the brain, it just attacks everything and causes a powerful immune responses, but also necrosis. So it kills brain tissue. So about 5 days after a person goes swimming, they'll get these symptoms like a headache and a fever, nausea, and ultimately that gets worse and worse as they get, as they get swelling of the meninges of the neck, and then they lose cognition, and they get seizures and ultimately death within a few days. So it's like 5 days after swimming, they start getting the symptoms, and 5 days after that, they're usually dead. There are only a small number of cases where people have survived this. Partly because there aren't really drugs that can go all through the brain tissue. So this is rare, but it's scary. We see it on TV all the time. There are a lot of examples where people have gotten it from warm lakes. Other examples, people have used neti pots to do nasal irrigation, and somehow they got water that had Naegleria fowleri in it. And I'm not sure how that happened. In at least one case, it didn't come from the tap. The tap water didn't have the tap water didn't have those cells, but something in the kitchen did. So it's just kind of scary that we don't know where these are. But again, very rare. Like one case per year, something like that. And since it depends on heat, we typically see it in the warmer parts of the country. But it's one of those things that's so spectacular that everyone should know a little bit about it. Okay, so then the other amoeba is the famous amoeba that causes amoebic dysentery. So this is Entamoeba histolytica. We don't have a clear idea of how common it is, but it is common, especially in developing countries, because this passes through the fecal-oral route. And we know that it kills at least 100,000 people every year, and there are carriers in the U.S. What we get when a person has amoebic dysentery, what they're experiencing is bloody mucoid stools. So basically the amoebas are attacking the epithelium and penetrating it and rupturing blood vessels, and they can even escape from it. So if you can imagine an amoeba that escapes the lumen of the intestines and travels through the bloodstream, will then go through the portal blood to the liver. And if it can attack the liver successfully and get out of the liver, then it's up against the diaphragm, and the diaphragm is not really meant to be amoeba-proof, so it can get through that to the lungs, and through that process kill a person. So the cysts are what we eat, and they're like a dormant form, and they sort of germinate in the stomach, and then attack the large intestine. The next group is the ciliates. This is group 3, and To be honest, I'm not going to tell you anything about this group because there's only one very rare pathogen that I'm aware of in this group. So we go straight from here to group 4, and this is the non-motile protists. One of which is Plasmodium that causes malaria, and that's going to be the last topic in this lecture and the biggest topic in this lecture, because malaria is the biggest public health problem in this lecture. Is it? Yes, it is. Malaria is one of the biggest public health problems in the world. It's one that public health people know about and want to solve desperately. So these are from the Epicomplexa phylum, and you can go back and find that on the left side of the big phylogeny I showed you. Let's get to it. So we start with toxoplasmosis, which is caused by Toxoplasma gondii. And this is a bizarre protist in that it infects up to half of all humans chronically without symptoms. So for all we know, you and I are infected with toxoplasma. And it's an obligate intracellular pathogen, which means it must grow inside host cells. And we typically get it either from eating the meat of an animal that was infected, or from being exposed to a cat, because something like 40% of the cats in the US excrete toxoplasma in their feces. And through their grooming, they contaminate their fur. And so if you pick up your cat and rub it against your face because it's fluffy, you could expose yourself to toxoplasma. We don't think about this very much because most of the time it doesn't cause any symptoms. But people with immunosuppression, like AIDS patients, again, they can have a really bad experience with this. They can die from this. And equally frightening, toxoplasma can cross the placenta. So if a mother contracts toxoplasma while she's pregnant, so if she gets a primary infection during pregnancy, it can cause stillbirth or brain damage in the fetus if the fetus does survive. Chronic infections apparently are not transmitted placentally. So a woman who was infected and may still be chronically infected is not as likely, or is not likely, from my understanding, to transmit it to her fetus. But yeah, if she gets infected while she's carrying the fetus, then the fetus is at risk. And that's why pregnant women are told not to clean cat litter boxes, etc. They should also be told not to eat undercooked meat. Yeah, look at this. This is the kind of thing I never want to see, which is decades after exposure to something, then you get the symptoms and signs. Yeah, that's horrible. So, toxoplasmosis is known partly because it does cross the placental barrier. So it is one of the torches pathogens. Torches is a mnemonic device from a textbook I used as a way of organizing the major vertically transmitted pathogens. So Toxoplasma, rubella is a virus, that's a virus, those are viruses, that's bacteria. There are other versions. There's torch. I think your textbook uses torch, where the T stands for toxo, the O stands for other, and there's a list of like 10 other things. And ultimately, this is not the comprehensive list of vertically transmitted diseases. There are a lot of others, but these are major ones. These are the most common, I believe, and some of the most damaging. Like, all of these could cause really horrible outcomes. Yeah, and usually there's no reason to treat this because there aren't any symptoms, but in a newborn you would definitely treat it. In a pregnant woman, you would definitely treat it. And there are drugs that can fight it off. The other reason you'd read about toxoplasma is that it is thought to change our behavior. So toxoplasma is well known to change the behavior of rats. Rats who are infected lose their fear of cats, or at least they lose their fear of cat urine. So when they smell cat urine, they don't hide from cats. So then a cat eats them and gets infected with toxoplasma. It's very clever on the part of the toxoplasma. There's also evidence that a similar thing happens in humans, that people who are chronically infected with toxoplasma have thrill-seeking behaviors and things like that. And we just don't know the contribution of toxoplasma to our own behaviors. Toxoplasma chronic infections are less common in the US than they are in developing countries. The only person I know who definitely has chronic toxoplasma was a professor who had a wicked sense of humor and swears a lot. So we liked to say that was her thrill-seeking behavior, but it's silly. This is the kind of thing that is difficult to analyze and difficult to say for sure what effect it has. The next ciliate we're going to look at is cryptosporidium, which causes cryptosporidiosis. It's mostly known in the US because of an outbreak that happened during a water treatment failure in Milwaukee, Wisconsin in the 90s, where hundreds of thousands of people drank contaminated water and all got sick at the same time. In a typical year in the US, we see something like 10,000 cases total. But what this showed us, and especially people who study environmental engineering and water treatment, like I did at one point in graduate school, what it showed us was that we have to be on the lookout for things like this. Because you never know when an animal will excrete large quantities of this into a water supply very close to where you take the water from. Right. So it comes from cows and sheep, and it's excreted in their feces. And typically we don't notice the infections. But people who are immunocompromised are at a lot of danger from this. So they could get cholera-like diarrhea. That's copious, watery diarrhea that can lead to death from dehydration rapidly. And so we do have some treatments, but for an immunosuppressed person whose immune system isn't going to finish it off, we don't have great treatments. So treatments are, as they say, discouraging. I did have students when I taught in Wisconsin who had been part of this outbreak. At least one of my students had been born in 1993 and was in the hospital with cryptosporidiosis. So you never do know. And again, this is, if there was an outbreak with 400,000 people, there can be another outbreak with 400,000 people. So it is worth knowing about this sort of thing. Right, and filtering the drinking water is the best way to prevent it. And part of the reason why I keep this in the course, why I'm teaching you about something that happened in Wisconsin, is this. Cryptosporidium shows us why it's hard to disinfect things. What we're looking here is a comparison of different organisms that could contaminate drinking water and how long it takes to disinfect them in chlorinated water. How long does it take them to die from the chlorine in typical drinking water? Well, one of the worst strains of pathogenic E. coli that we know of dies in a very short amount of time in chlorinated water. So you don't have to worry about getting this from your tap water. Hepatitis A virus and even to some extent Giardia in a typical urban water supply they won't survive because they will be killed by chlorination, and Giardia would be filtered out. Cryptosporidium takes something like 10 days to be killed in those conditions. And so what that tells us is that if you want your water, your drinking water, to be safe, you can't just chlorinate it. You can't just filter it. You have to use at least one physical method to remove things like Giardia, Cryptosporidium, and one chemical method to kill things like viruses. It's tricky. It is a tricky thing. And that's enough of that. So the last video today is going to be about malaria, and that's where we'll leave this very long lecture. So I will see you there.